Hello everyone, Monkhouse here. I'm really excited to bring this video today. We're going to, by the end of this video, you're going to be able to do a number of things. We already know how to open an image. I'm going to show you how to convert that to grayscale using the Python imaging library. We're going to use matplotlib to plot that image then as a histogram. I'm going to explain what a histogram is, of course, and we're going to build some intuition about what it is and how it works. On top of that, we're going to play around with numpy arrays, just so you can see what's going on. So again, developing intuition on how they work, and then I'm going to show you how you would implement your own grayscale conversion algorithm. So if you want to learn any of that, then stick around for the video. I recommend watching it all, it's pretty good. Yes, thank you for watching and see you in a minute. Hello guys and welcome back. Get started, hang on, let's make the screen a bit bigger so everyone can see what's going on. We're going to navigate to our usual directory, and we're going to go into our a.py, which we always use, and I'm also going to make this a bit bigger just so everyone can see. Right, so I want to say quickly, I really recommend sticking around for the whole video, but I am going to show you really quickly, if you're interested, how to actually just plot the image as a grayscale image. So just a little background on what grayscale is, you might already know, but what it essentially does is it removes all of the color information from our image and then converts it into a luminosity, well, into luminosity values, or lumo, or brightness as a way of thinking about it, like light intensity. So we can actually do this really easily with a method provided to us from the Python imaging library, or Pillow, the fork of it, and all we need to do is L. So we convert it to L, which stands for lumo, which kind of is luminosity and light intensity. Think of it as that, to remember it. And there's a bit more we need to do though, because if we actually try to plot this, then our Python's fit. It doesn't like this, and the reason is it just doesn't want it in this format. So we can just go back to our script and bring it over to the right hand side and make it a bit bigger. And what we need to do, and this is going to be, we're going to be doing this a lot in the future, we're going to import numpy as np, and we're just going to convert this into a numpy array. And we do this simply with np.array, like so, and then we've got an array now. And with this array, it's going to allow us to plot our grayscale image. Well, it's try to, but one thing we've actually forgotten to do is we've forgotten to tell matplotlib that that it's a grayscale image. So we need to tell it. So we're going to say, look, this is a grayscale image. So when you plot it, think of it like that. So there's our grayscale image, and we can actually see, if you remember the original picture, we know that we've got an egg here, and we've got fork, and we've got another fork, but the whole rest of the image is basically approximately white. It's closer to white than black, at least. It's almost a white color. So we can actually plot a graph called, sorry, let's make this bigger again, called a histogram. And we're going to plot this afterwards. And a histogram is really good because it tells us, oh, by the way, before I go on to the histogram, this conversion is based on a really simple mathematical formula, and we're actually going to look at it later a little bit, but it's essentially this. So you know that our image originally, which is RGB, it consists of 3 color channels of red, green, and blue. And so what happens is we have a pixel, and that pixel has an array, and that array consists of 3 values, red, green, and blue. So what we can actually do with this information is we can convert it into, by treating them as decimal numbers almost, we can convert it into one whole number. So we could do our red color times it's 0.2, so this is the equation given to us on the Python imaging library. There's a few different sources for different values, but I think this is a pretty accepted one. And then our green color times 0.587, and sorry, this is a plus sign, guys, ignore me. and then we're going to have our blue value, which we would multiply by 0.114. Now if we add those values up, we actually get 1, which makes sense. So we would have this 1 value instead of 3 values, because we've added 3 fractions that add up exactly to 1. And this gives us our value. So it's kind of saying, when we're creating a grayscale image, most of the information comes from green, then red, then blue, in terms of brightness at least. So maybe we just comment this out, and we can keep this here for now, because obviously there is no RGB. But just know that that's all this is doing. It's doing that for every single pixel in our image. So let's do our histogram. So we're going to do our histogram. So let's create a new figure, and this is going to be it's just hist. Sorry, I was looking up, I'd forgotten what it is. We're going to do PLT hist, and inside of there, what we need to really do is we actually need to I actually already know this in advance, but so let's just put our image in first, right? Let's see what happens if we do that. We're going to get an error message. We should do, although I feel like I may have frozen the program. So either way, it doesn't like this. So what I'm going to do is I'm going to come out of here. Let's close this terminal, and let's go back to our terminal, and let's make this a bit bigger. And we're going to go cd into A, and we're going to open our Python script again and do a.py. So let's make this bigger. So essentially we don't want to do this. When we print this array, let's print this though, for the sake of it. Let's print im. But I'm going to do this so it doesn't freeze again. Actually, what we can do is we can come up here and we can print im.flatten, just so we know what's going on. This is a function, of course. And let's comment this out. So we've run the script now. Let's run our script, python a.py. So this is our first array, and this is once we've flattened it. So notice in this mode here, we don't have this sort of extra bracket, extra square bracket. It's just the raw values. Now this is the input it wants for the histogram. It just wants the raw values. So we can use flatten to give it that. Otherwise we get an error. So let's close these two image files and go back to our script. So hopefully you understand what that did. And we go back and we can get rid of this line now because we don't care about it. So let's plot our histogram. And there's another key bit of information we're going to be looking at in a second, but first let's plot this. So automatically it's going to choose a suitable number of bins for us. Hang on, we've made a mistake. Oh, this isn't a function. So there you go, this should now work for us. So automatically this has actually chosen something called bins, and I'm going to explain what a bin is in a second. But what we essentially have, we said that most of our image is white. So what does that mean? Well, when it's grayscale and when we're referring to brightness and luminosity, 0 is black and 255 is white. And as most of our image is white, it's not surprising at all that most our pixels have kind of been put over here towards the 255 mark, or the 250 mark in this case. And the least amount of pixels are in this kind of middle mark around 120 on this grayscale image, which is kind of grey. That makes sense. If this is black and this is white, then this is grey. So this is our egg, some of our, like this, maybe this shading here. So we've got, you might be wondering like, well, how has it decided this value? And this is something that they call a bin. So I actually want to talk about that because it's good to understand it a bit more intuitively. So if we did 1, I'm actually going to do a simpler example, and I'm just going to leave this as a number like 255. And we can ignore this for a moment. In fact, let's comment it out. I'm just going to create a whole new array. And this is going to be a different figure. And in this figure, we're going to plot another histogram. And this is already going to be flattened. We're just going to give it a list of 1, 1, 1, 1. And our number of bins, which is this is bins. We don't need to put anything, but this is what I'm referring to. So this is our number of bins, and it's 1. Now what this is going to do essentially, when we plot it, it's going to say, well, all of our data is somewhere in our data, because this is automatically generated. Our x-ray is automatically generated. It's looking, you know, if we put the number 100 in here in our array, then this value over here would be 100, because it knows that that's the largest value. Now it's saying we've got 5 numbers, which is correct. We've got 5 ones in the array, and it's saying that all of those are in this range. That makes sense. Well, sort of. Let's build that intuition up a bit. So if we go back into our editor, what happens if we do 2? You'll be able to understand this now, and we're actually going to see that it likes to round upwards. Now that we've split it into 2, it's saying, look, well, all of our values are 1, and so all of your data, if you split it into 2 bins, so splitting our x-axis essentially into a number of bins, if you split it into 2, then all of our values are on the right hand side, 1 plus, because it likes to round up. It could just as well round down, but it likes to round up. So it's saying that all of our 5 values are somewhere between 1 and 1.5. I hope you're following with this. It did confuse me a little bit to begin with, actually. So let's move this over to the right hand side again and make it bigger. As always, I need to actually change the settings to do it permanently. Hopefully now, by putting a 3 in, you'll be able to understand what's happening a bit better. This is where I got it. So let's run this script. Not sure what's happened there. Ah, there you go, it's done. So notice now how the bottom axis is split into 3. That's what it's doing. These bins are essentially splitting the axes. It's split it into a third. You've got a third of it here, a third of it here, and a third of it here. And it's saying, look, all 5 of your values are in this third, which is correct because all of our values are 1. And when it was split into 1, it was still all the values were still 1, but it was just that our bin was 1, so it represented the whole axis. When we split it into 2, it represented just half of a bin represented half of the axes, and it likes to round up. So in this case now we've split it into 3, and now it's saying, well, it's in the middle thing. So if we close this and we close this, you'll be able to see a trend now. If we make this 20, it's going to split our axes into 20. And essentially what ends up happening is the larger this value gets, the more precise it is. It's saying, look, we'll split our axis into 20 values now, and all 20, by doing this, we've identified that all 5 of those numbers in the array are 1. So anyway, I'm banging on a bit there, but hopefully you understand that now. So now that we have some intuition for that, we're basically saying that the more bins we have, the more accurate these values are going to be. So we can go back now and plot our thingy, and let's make this large, this image. And now we can see that there's nothing black in the image, and there's some stuff that's exactly white almost, but most of it is here. Most of our pixels are this color, which is 236, which is almost white. So yes. Now I also want to go over a bit more still. So if you're not bored yet and you're finding this interesting, then stick about. Again, we need to make this bigger so everyone can read. What did I want to do? So I wanted you guys to kind of build a bit of intuition about what numpy is doing and how that's working. So what we're going to do, we're actually going to reopen our image at the top here. And this time we're just going to use the image class, and we're going to open egg.jpg once more, and we're going to use the 2 attributes that we learnt before, and we're just going to print different keyboard. We're going to print the width, whoops, we're going to print the width, which is going to be im.width, if I could spell. And we're also going to print the height. Actually, I want to do that. So we've got our height value and our width value. So this is obviously going to tell us how many pixels wide it is and how many pixels high it is. The other thing I want to do is, so by the way, I'm redefining image here. So at this point, image is just this object, and then at this point, image is going to be this grayscale object. So let's come into here, and what I want to print is the shape. And we should probably, yeah, let's just go and make sure that we can actually read that and decipher it. So we're going to print the image shape, and we're going to print the image as well, as in when we print the image, we're just printing the array values of the image, not the actual image itself. And I don't want to show this, so we can comment this out for now, and later we can show it again if we want to. So let's quit and let's run Python. So we've got our width of the image, it's 500, and our height is 667. But the shape of our numpy array is 667, 500. So it's actually doing it a little bit differently, but it does make sense. And the reason it makes sense, if you think of an image, you can even consider this screen here an image, right? So here's your vertical and here's your horizontal. And if this consists of, say, 667 pixels, then this is going to be 667 rows, and there's going to be 500 columns. So each row has 500 columns. You can think of the height as the row and the width as the column, but don't get too confused about that, because I'm going to show you now what I mean by that. Let's make this bigger again. And what I want to do is, let's just create a little array so you can visualize this a little bit more. We're going to just come in and we're going to say x2, it doesn't really matter, equals mp dot random dot random, and we're just going to fill it with some values between 10, and then our size is going to be 3, 4. So from what I said before, how do you think right now this is going to look? Well, we already looked at the screen over here, and we said, look, the shape is 667, 500, and I said this is rows and this is columns. So what we're doing right now is we're creating an array which has random values between 0 and 10, and it's going to have 3 rows, and each row is going to have 4 elements or columns. It's kind of how you can think about this. And I can prove this to you by doing what we just did before. We're going to print, let's print the shape, and we're going to call it x2 shape. x2 shape, and this is going to be our x2 dot shape. So we can now compare that to what we've just done a moment ago, and we can also, let's also print the actual whole array, just so we can understand what's going on there. So Python size not defined, what have I done here? Oh, the reason for this mistake is because once you are explicit, then you need to be explicit always, essentially. What have I done? Oh, no, I'm lying. This is a parameter. So because it's a parameter, we're saying this needs to be equal to that. So we're saying this is our size, it's going to be 3, 4. Okay, so let's try that again. And there you go. So what have we got here? We've got our width from our original image, our height, and then when we set the shape of that, it's actually rows. So the height represents the rows and the width represents the columns, which makes sense when you think about it for a moment. And in the same way, we created this x2 array, and the shape of that is 3, 4 with 4 random numbers. So we've got 3 rows like this, and each one has 4 columns, which is our 4 elements. So this is how our numpy array is working. That's what it's doing. This is kind of the intuition behind it. What else do we want to do? Let's make this bigger again. We've covered quite a lot there. I think one final thing that I want to give a little go in our editor, and we're actually going to convert our original image, which hasn't been converted to grayscale, and we're going to turn that into an MP array. And we need to get rid of these 2 attributes because they are image attributes, not numpy attributes. But what we can do now is we can come in here and say original image shape, and that's just going to be im.shape from above, and we can just print our im as well. Although we don't really need to do this, but let's do it anyway. So if we actually make this a bit bigger and we come over here to this side, so our original image shape now is 667, 500, 3. What's the 3? Well, that's because we said before we haven't converted this to a grayscale, which means now each pixel actually has a 3-element array. And in this case here, we can see that the element at 0 is 255, 232, 218. So this is saying our red is 255, our green is 232, and our blue is 218. So let's actually do something with that. So let's come over here, make this a bit bigger so everyone can see. And where was this? So that's our original image. So what did I say our values were? So I'm just going to quickly comment in what those values were. They were 255, 232, 218. And what we can do now is I'm just going to do a simple for loop, just so I can quickly let's do, just so we can print it. And I'm going to go 0 to 3, and inside here I'm going to do print, and this is going to be our image, and we're going to look at the spot at location 0, remember? So this is 0, 0, this is 0 high, and 0, well, it's in the top left corner if you remember from a previous video, and then this value here is going to be I, and this is going to be our red, green, blue channels. So if we quickly just not print anything else, well, from below, then what we'll be able to see, if we come down here, so we've now printed our values. Let's open our emux a.py, bring that over. If you look what the values we had over here, 255, 232, 218, and that is in fact what we've managed to print. Now, going back to what we did earlier, down here, so down here we've got L equals R times, these are our values essentially to get our luminosity, sorry. So what we could do now is we could say R is equal to 255, and we can say G in this case is equal to is equal to 232, and blue is equal to 218. Now this should theoretically give us a whole number, but I've already experimented with this and it actually didn't. So what we're going to do is we're just going to come up here and we're going to import math, and we're just going to floor it. We're going to do math.floor these values, and then we're going to print our L value. So I'm used to a different keyboard, keep making typos, used to my ThinkPad. This is going to be our L value, and this is just going to be L. So hopefully we haven't made any mistakes here. No longer care about this. So we've just calculated an L value, I think. So there you go, we've got an L value. it's 237. So what we're basically saying is that element 0 is 237 in terms of our grayscale values, and you would do this for every. So you'd do a for loop. You'd basically say for each pixel, do this calculation. That's what you would do. So you'd say for each column in each row, do this calculation. And if you remember, so what I'm going to do, I'm just going to do one last thing. We're going to do plt.imshow im just to actually show our original image. And I'd actually forgotten that this isn't quite white, but in terms of this, if we convert it to grey, I mean, in terms of its brightness, it's basically, it's not saying that it was white, to be fair. It's saying that it's closer to white in terms of brightness, which it kind of looks like. It's not very dark. So this is the point that we've just decided is 237, which seems about right. You can see these bits here, just on the round side of the egg. They're probably the bits that are completely white. And then this is darker still. This is the values that are probably 127 and so on. Anyway, that was a lot of information, and that was a long video. I hope it was useful though, and I hope you watched all of it, or you got something out of it. Again, check out my website. The link is in the description. Leave a comment if you have any questions or ideas for, or if you, just leave a comment if you have a question, and I'm happy to answer it. If you like this content and you're interested in computer vision, which is where this channel is going, then I advise you subscribe, or not. It's up to you. Or you can subscribe on the website and get emails and stuff. But yeah, thank you for watching, and I hope to see you again.